Bismillahirrahmanirrahim. Okay, this is going to be a review before we start. So everything is based on the unit circle, so you really have to know the unit circle really well. So we're kind of going to relinquish the 360 degrees business, right? So this is going to be 0 radians or 2 pi radians, and this is going to be pi radians, and this is going to be pi over 2 radians, and this is going to be 3 pi over 2 radians, okay? And then so I hope you understand 360 and 180, 90 degrees, and 270 degrees. So those are kind of things that we have to know really, really well. And then among these, this is the first quadrant is the most important for us to know, because you can extrapolate everything from there. So this is 30 degrees, okay? That's going to be pi over 6 radians, okay? Because 30 degrees will give you a pi, right? So if you have a pi, you're going to be able to cut it, for 6 people. Okay, so this is 30 degrees. And this is 1/3 of a pi, right? Pi over 3. And 45 degrees, okay, that's going to be 1/4 of a pi, right? So there are 3 of these in 1 pi. Does that make sense? Okay, so this is really important. And then after these, the way in my mind I generate these values is just imagine these triangles in my mind. So this is a 30, 60, 90 triangle, and the long side of the triangle, the long leg of the triangles is kind of resting on the x-axis, so that's going to the bigger value. That's square root of 3 over 2, and the short leg is standing tall, so to speak, that's 1/2. This is square root of 2 over 2, and this is square root of 2 over 2. And this is, again, 30, 60, 90 triangle. It looks kind of funny because the screen is kind of stretched there. So, but this is going to be, the long end of the triangle is going to be the y value, and the short end is going to be the x value, like this, right? So that's how I generate these values, okay? I don't memorize them, stuff. And then from here you can extrapolate all the rest of these values, right? The only thing that's going to change is the sign, right? So in this quadrant, both the cosine and the sine, this being the cosine of, right? So this is cosine of pi over 6, and this is sine of pi over 6, correct? And same thing with all of these. The only thing that's going to change is the signs, right? In the first quadrant, both the cosine and the sine are positive. In the second quadrant, the cosine is negative and the sine is positive. In the third quadrant, the cosine is negative and the sine is also negative. And in the fourth quadrant, cosine is positive and the sine is negative. Okay? But I should have labeled these 0 as 1, and x is 0, 1, negative 1, 0, and 0, 0, negative 1, right? Okay. So I just want to tell you one more thing about these, okay, which we didn't talk about before. Just the signs change. It's easy enough, right? Okay. Now, we did suggest before that tangent of theta is sine of theta over cosine of theta, correct? All right. So if you divide a positive number by a positive number, you get a positive number. So in the first quadrant, both the sine and the cosine are positive, so the tangent will be positive, right? In the second quadrant, the cosine is negative, sine is positive, so the tangent will be negative. In the third quadrant, tangent will be positive, and in the fourth quadrant, tangent will be negative. Okay? So positive, 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 negative, positive, negative, 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 positive, positive, negative, negative. Okay. Now, that's pretty intuitive. You can derive it, right? So, but there's a mnemonic that helps you remember this, and it's actually handy dandy mnemonic, because sometimes you just don't want to think through everything. You know what I'm saying? It takes a while to just think through everything. So the mnemonic is all students take calculus. I like this one because it's kind of like, you know, preps you mind, kind of subliminal message type of thing, you know. So what this says is all students take calculus. Okay, in the first quadrant, all of them are positive. In the second quadrant, the sign is positive. In the third quadrant, only the tangent is positive. In the fourth quadrant, cosine is positive. Do you understand? It tells you which one of them are positive. In the first quadrant, all of them are positive. In the second quadrant, sine is positive. In the third quadrant, tangent is positive, right? And in the fourth quadrant, only the cosine is positive. Okay, this is important because sometimes, like, you know, standardized tests, they ask you simple questions, and you can answer that in 2 seconds if you know this, and you answer it in 30 seconds if you don't know it. You know, and since seconds matter, it's important to know. So in the first quadrant, which one of them have positive numbers? All of them. In the second quadrant, which is positive? And the third quadrant, which is negative? Well, which is positive? And the fourth quadrant? Cosine. Okay? All students take calculus. All students take calculus. Okay?
What
That's...
What does that mean? Like all are positive, sign is positive?
The sign. So here, in terms of, you see that this is a positive value, that's a positive value, right? So a tangent will be a positive number, too, right? Positive divided by positive is positive, right?
Okay.
You follow?
Okay, sign of the cosine, okay,
Yes. So, and in this case, tangent will be, right, because it's sine of gerene or cosine of gerene, tangent will be negative, right?
Yeah.
Okay. So this is a mnemonic, just helps you remember the signs of each of these, what if they're positive or negative in each quadrant. Does that make sense? Okay. And that's just a handy dandy tool. It's not that you cannot derive these quickly if you needed to, but this is just faster way of doing that. Does that make sense? Okay. Now there's one more very, 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 very important concept. Understand? Okay. Now watch. I'm going to erase all of this except for the first quadrant stuff, okay? Okay, now look. I need this. 1, 0, 0, 1, negative 1, 0, and 0, negative 1, right? Okay, let me just ask you, make sure you understand. What's the cosine of 0 degrees?
The
Cosine of 0 degrees.
Wait, no, that's 0, 1.
What's the cosine of 0? So cosine of 0 is? 1, because it's x value, right? So cosine of theta, sine of theta, right? So it's the ordered pair, right? What's the ordered pair at 0? It's 1, 0, right? So that's cosine and that is sine. So cosine of 0 degrees is? 1. Sine of 0 degrees is? 0. What's the cosine of 45 degrees? Okay. What's the cosine of 180 degrees?
0. Or
Negative 1. Very good. What's the sine of 270 degrees, Abdullah? Sine of 370 degrees. 270, I meant. This is 270, right? What's the sine? Negative 1. Does that make sense? Okay. Now, every graph is domain and range, right? What's the range of all cosine values here? Range, right? Range. What's the range? Cosine ranges from what to what? All cosine values.
Oh, no. Negative 1 to 1.
Oh, from
Negative 1 to 1. So let me ask you, what's the cosine of 740 degrees? And somebody said 7. You said, don't think so. Yeah? Because the maximum cosine is 1, and the minimum it can be is -1. So the range of cosine is from -1 to 1. Therefore, when you graph the cosine graph, the range, which is the y values, will range from 1 to -1. Right? That's the range. Do you understand, Abdullah? So the range of cosine values is from what? They will never be higher than that. Right? So if somebody says, what's the cosine of, 185 degrees? Then you say, yeah, it's -2. Oh, yeah, you're right. You know what they're talking about, yeah? You follow? That's the range. Okay? Now, what's the range of all the possible sine values? What's the range of all possible sine values? Same thing, but from here, right? Does that make sense? So when you graph sine curve, the range is still going to be from there to there. So neither of these graphs will go higher than that, correct? So, for example, y equals, let's do sine of x. Look at this. What's the maximum value here? 1, right? What's the minimum? -1. Okay, y equals cosine of x, the same thing. Okay, where's cosine? Yes? Cozy cosine, right? Remember cozy cosine? Starts from here, goes down here. What kind of hammock would sine make? Not a good one, right? You understand? Cozy cosine. Okay. So now, did I say that what I'm teaching you right now is like important? Yes? No. I said it's very, 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 very important. Yes? Yes. It's very important. Understand that the range of cosine and sine is both positive and -1. Now this is tricky. Okay? Now watch. Now I ask you, just to make it easier, right? I ask you, what's the cosine of 0 degrees? What's the answer? 1, correct? 0 degrees is 1. What's the cosine of 360 degrees? How about 740 degrees? Yeah? 360 times 2? Yeah? So, but if you punch in the calculator for this angle, look, and if you punch in the calculator on this angle, it'll give you the same sine and cosine values, right? Yes or no? It will. Okay? The original angle, okay, the basic angles from 0 to 2, these are called reference angles. So all the angles that are bigger than these reference angles in 360 degrees, they'll have the same sine and cosine values. Does that make sense? So if you type in anything that's bigger than 360 degrees, it will just revert back to the reference angle. Does that make sense? So, true or false? If you were asked to graph sine curve or cosine curve, if you graphed one cycle, right? That would be representative of all other angles, yes or no? Okay, so that's one point. Does that make sense? Okay. Now, let me ask you this, okay? So look at this. The cosine value goes from here to here, right? The maximum one, from 0 to 300. The sine values go from maximum from 1 to -1, right? From here to here, okay? You follow? Correct? From +1 to -1. In other words, from like 90 degrees to like -90 degrees, right? Okay, you follow? Watch this. No. Now look, from sine values from here to here, right? Look at that. From here to here. You see this? Sine values. From +1 to -1. Do you follow? So these will give you all the potential values of sine. Okay? Because to get from 1 to -1 here, from here to here, that's all the potential sine. Now the cosine values from here to here, right? Do you understand that? All start from 0 to 1. I'm sorry. From cosine, I'm sorry, I looked at the wrong graph. From here to here to here for sine, right? From the cosine, from here to here. Got it? Okay. How about for tangent? What's the range of tangent? Oh, it's a tricky question. I shall give you a minute to think about the range of tangent. What's the range of tangent, you think? Now, I'll give you a hint. So tangent of theta is sine of theta over cosine of theta. What's the range? You know how we said for sine and cosine it's 1 to -1, right? Right? So what is it? How so? Now look, sine, okay, in the graph that we drew, it's like here, right? Okay, x is this, y is that, right? And then you go over here, okay, x is this, y is that. As you keep getting closer and closer to the 90 degrees value over here, the sine will get bigger and the cosine will get smaller, right? So, okay, sine will get bigger, cosine will get smaller. And then you get even closer, you get bigger, and you get smaller. Now, what's the tangent, okay? What's the tangent of 90 degrees? Well, what's the sine of 90 degrees? And what's the cosine of 90 degrees? Oh. Now, what's the tangent of 90 degrees then? Oh. Haram. Haza haram. You understand? It's undefined. Yes? Now, let me ask you that. Now, what's the tangent of like 270 degrees? Huh? Undefined. So every time it comes over here and over here, it's going to be what you're going to find in that graph. An asymptote, right? Anytime the denominator is undefined, you'll find an asymptote. Okay? Good question. An asymptote is a line that the function of the graph approaches but never reaches. We have seen those before. Yes? We've seen asymptotes. So, let's graph it. Ready for this? Abdullah, you ready? I know. I don't look ready. You look ready. Are you ready? Y equals tangent of, ready? You see that? Ooh. It's going to have lots of asymptotes. Every time it's undefined, it's going to be an asymptote. Okay? So, where was the first asymptote you encountered? Now we are in radians. X is equal to, it was 90 degrees, right? First asymptote. And I'm going to draw a vertical line there. 9 pi divided by 2. Ta-da! You understand? And then here, I'm going to draw another vertical line. X equals negative pi divided by 2. Ta-da! You see that? Those are the first two asymptotes. Let me get rid of these to make it easy for us. Do you see this? Those are the two asymptotes. Does that make sense? Yes, sir.
So asymptotes are lines that never reach.
No, asymptotes are the lines that the graph approaches but never reaches.
On the graph.
They're not on the graph. They're not part of the graph. It's like you're going to touch the cookie, but it ain't going to happen. It's a sad ending, huh?
They're imaginary lines?
Well, they're true. They're lines that help you understand the graph. You follow? If you just graph tangent of x, it didn't come with the asymptote. It's just Do you understand that? So the graph of tangent is going to look like this, right? So if you wanted to graph tangent as a representative of all angles, you would graph it from negative 90 degrees to positive 90 degrees. Negative 90 degrees, right? You understand what that means, right? Yes? Right here. So you would graph that function from here to here, right? Because that's where you get the two asymptotes. So if you graph tangent from here to here, then you have picked up one of those slices of tangent. That will be represented. Now, any angles, so it's just like cosine for being from negative 1 to 1, sine being from negative 1 to 1, tangents are going to be from this infinity to this infinity. Yes, sir.
And that means that like tangent is not like some of it is real and some of it is fake, some of it is on the graph. Because those two values, they're not undefined, right? So then that means only like it has some of that line is asymptote, but some of it is not.
No, only two values are not defined. Positive 90 degrees and 270 degrees. Those are the only 2 points. Because every other point, the domain of tangent, okay, is going to be restricted for 90 degrees and every 180 degrees thereafter. So this value is not defined, this value is not defined. And then you go back another 180 degrees, not defined. Then you go back 180, not defined, not defined, not defined. That's every time you get multiples of 180 degrees starting at 90. Does that make sense? Okay. So, now I say this as introductory remarks because we kind of have completed chapter 9 and we're going into chapter 10. We're going to graph all these functions. Okay? After a brief pause, inshallah.